Hi Math 2. Today we're reviewing factoring. You learned how to factor last year in algebra, first in Unit 6, and then you continued to use factoring in Unit 7 last year to solve quadratic equations. So let's begin by factoring a GCF. GCF stood for greatest common factor. This is basically reverse distribution property. You look at every single term in your polynomial and you factor out the greatest common factor. This first polynomial is a binomial because it has two terms. And these two terms, when I look at the integer part, they both have a 7 in common. And when I look at the variable part, they both have a y to the first power in common. So a greatest common factor here is 7y. So I'm going to pull it out in front, open parentheses. I'm going to factor or divide 14y squared by 7y. 2y is left over. And I'm going to divide or factor 7y from 21y, and I'm going to have 3 left over. This is 14y squared plus 21y in factored form. And you can always check that you did your answer correctly. When you factor, the way you check is you multiply your answer back out. You should get your original polynomial. So let's continue with the next problem. More of what you're going to be doing on this worksheet is factoring a trinomial. This is a trinomial because it has 3 terms to it. And so I look at each term and I look for a common factor. And if there is one, I factor it out. In this case, I only have a common integer factor, and that is 2. So I'm going to pull the 2 to the outside, and I have x squared plus 5x plus 3 when I factor 2 from each and every term in my trinomial. Again, I can double check by distributing the 2 back into my trinomial. So let's review factoring a trinomial that is factorable, that has an a of 1. That means the first term, the coefficient term of my x squared term is 1. So these problems can be done in different ways. Last year we worked on the diamond method, the x method, and so we would create our x or our diamond to help us with our work. And the top of my x would be my a times c, and the bottom of my x would be my b term. The top of my x is the number that my side numbers have to multiply to, and the bottom number is what my side numbers have to add to. And then I would look at my trinomial for my a term and my c term. In this case, the coefficient of my x squared is 1, and the c term is negative 20. 1 times negative 20 is negative 20. And then my b term is what's in front of my x term, and that would be negative 1. And so I'm going to put negative 1 in the bottom. So now I'm looking for 2 numbers on the side. I want the 2 numbers to multiply to this, oops, sorry, I thought I was on my highlighter. I want the 2 numbers to multiply to this negative 20 on top, and I want them to add to this negative 1 on the bottom. So this is where I use my math skills and I come up with, for example, 4 and 5, and then I test those out. In order for them to multiply to a negative number, one of them has to be negative. In order for them to add to a negative 1, it needs to be the 5. So 4 times negative 5 multiply to negative 20, and 4 plus negative 5 add to negative 1. These are the numbers then that go in my parentheses. It doesn't matter which one I put first. Either one is fine. I could have wrote my answer as x minus 5 times x plus 4. Order doesn't matter here. And if you want to check your answer, you always can. If you FOIL or box these 2 binomials, you should get x squared minus x minus 20 back. So let's take a look at another one. always look for a GCF first. If you don't, you'll usually see it in the end and be able to take it out in the end, but it does tend to make your math easier because it makes your numbers smaller to work with. So in this case, for instance, as I look at this problem, I notice that my coefficients are 2, 14, and 12. They're all even. So I'm going to factor out a 2 before I get started. And when I do that, I have x squared plus 7x plus 6, and then I start my process. I create my diamond. At the top of my diamond is my a times c. In this case, it's my factored form. So there's an 1 in front of my x squared, and my c is 6. So that would be 6. That's what my two side numbers are going to multiply to. And then the bottom is my b. So I look at my b term, my coefficient of my x, which is 7. And I'm going to write that down here at the bottom. And now I'm thinking of two numbers that multiply to 6 while adding to 7. My choices of multiplying to 6 are 2 and 3 and 7 and 1. And so when I think about what multiplies to 6 while adding to 7, I'm thinking about the 6 and the 1. The 2 and the 3 would add to 5. So 6 times 1 would be 6, and 6 plus 1 would be 7. So I forgot my little plus sign right there to help me remember I'm adding to that. So then when I factor, don't forget your greatest common factor in front. And this becomes x plus 6 times x plus 1. Order doesn't matter. And again, if I want to double check my answer, I FOIL or box my two binomials, and then don't forget to distribute your 2 through. So you can finish up numbers 3 through 6 on your own to practice. The next style of factoring that we learned last year was factor by grouping. When you do factor by grouping, there are, for example, 4 terms here. And we group the first 2 together and the last 2 together. And then we look at our grouping and we look for the GCF. So x squared plus 2x. Both of those have an x in common. I'm going to factor out an x, and I'll have x plus 2 when I divide the first term by x and when I divide the second term by x. So now I pause and look at the 4x plus 8. They both have a 4 in common. So I'm going to factor out a 4 and have an x plus 2. When you get to this step, you should notice that what's inside your parentheses matches. If what's inside your parentheses does not match, you have made a mistake and you need to relook at your setup. So in this particular case, once I do this, I have 2 terms here. My first term is x times x plus 2. My second term is 4 times x plus 2. Both of these terms have an x plus 2. So my last step is I'm going to factor out that x plus 2 from both of them. When I do that, in my first term, when I factor out an x plus 2, I have this lone single x left. And so I'm going to write that inside my parentheses, plus. And from my second term, when I factor out my x plus 2, I have this lone single 4 left. And so in my parentheses, I will have x plus 4. You might notice, if you're looking at this, that in this problem, we could add the 2x and the 4x together and get 6x. Don't do that in this case. Part of the skill you're learning is how to factor trinomials where the a is not 1. We're going to use factor by grouping to do it. So you really don't want to combine those 2 middle terms. If you did, you would get the same answer that I did, x plus 2 times x plus 4, but then you're not learning to factor when my a is not going to be 1. So let's look at another problem. Let's take a look at number 11. So again, I'm going to group the first 2 together and the last 2 together. When I look at the first 2, and please notice on this problem, you can't combine anything. This is a 4-term polynomial that you can't combine. So as I'm looking at number 11, I look at the first term and notice that they both have an 8 in common. And they also both have an r squared. So r to the second power is the highest variable that they have in common. In the first term, 8r cubed divided by 8r squared would leave me with an r. And 64r squared divided by 8r squared would leave me with a negative 8. So now I look at my second term, r minus 8. They have nothing in common. Be really careful here. I'm going to factor out a 1 then. R divided by 1 is r. Negative 8 divided by 1 is negative 8. And I have r minus 8. This is a really important step because now I'm going to factor out my r minus 8, which is in both terms. So I'm going to write that in front. And I'm going to write my leftovers in parentheses. This is where it's really important that I have the plus 1. This is so that if I wanted to FOIL or box, I would get the exact same original polynomial back. And so it's really important to have that plus 1. So you can try 8, 9, and 10 and check your answers in Google Classroom and bring any questions you have to Zoom. Next, we're going to review factoring quadratics with a leading coefficient greater than 1. In other words, in these problems, my a term is something other than 1. I have to factor these more carefully, and there are different methods to do this. The box method, slide and divide. We're going to use factor by grouping because it's what your Math 3 Enhanced teacher will expect you to be able to do. So let's take a look. The procedure begins exactly the same as it did on the front side when my a was 1. So remember, my a is 2, and when I look at the 2, 3, and the negative 9, there's no GCF to factor out. Sometimes there is, and the problem becomes a little simpler. So let's take a look at my setup. Remember, at the top is your a times c. Your bottom is your b. This is the number your side numbers multiply to. This is the number your side numbers add to. So on top, a times c, 2 times negative 9 is negative 18, and your b is 3. So now I think of things that multiply to negative 18 while adding to 3. If you're having trouble coming up with these numbers, you could list out the factors of 18. 1 times 18, 2 times 9, 3 times 6, not 4 times anything, not 5 times anything, and now I'm back to 6 times 3. As soon as I get back to what I already had, I'm done with my factors. And when I look at these, the only choice for my side numbers is the 3 and the 6. Because if I put 3 and 6 here, when I multiply 3 times 6, I do get an 18. Now, in order to get negative 18, one of the two of them have to be negative. So I need to decide which one. When I look at the fact they have to add to a positive 3, that helps me determine that my negative 3 is my negative number. When I multiply negative 3 times 6, I get negative 18 on top. When I add negative 3 times 6, I get a positive 3 on the bottom. Now be careful, do not put these in parentheses. I rewrite the 2x squared, I rewrite the negative 9, and now instead of writing a 3x, this is where I'm going to insert my two side numbers. I'm going to insert the negative 3x, and I'm going to insert the plus 6x. These are the two numbers in the side of my diamond. Notice that these two red middle terms do equal my positive 3x, but I've split them up because now I can do my factor by grouping steps. I can factor the first two terms and factor my last two terms. So when I look at 2x squared minus 3x, I notice they only have an x in common. So I'm going to factor out my x and have a 2x minus 3 left over. When I look at positive 6x minus 9, I notice that they have a 3 in common. So I'm going to factor out a 3, and I notice that 6x divided by 3 is 2x. Negative 9 divided by 3 is minus 3. And again, just like in the problems you did on the other side, what's in parentheses should match. If it doesn't match, you have a mistake somewhere. So now that I have that set up, I'm going to factor 2x minus 3 out of both terms. In the first term, it leaves me with an x. In the second term, it leaves me with a plus 3. And I'm all done. At this point, if I want to check my answer, this is when I can use my FOIL or my box method to multiply this back out to see if I get my original trinomial 2x squared plus 3x minus 9. Let's take a look at another problem. So in the next problem, I'm going to draw my diamond. And at the top of my diamond is my a times c. That's what my numbers have to multiply to. And the bottom, my number is my bottom is b, and that's what they have to add to. So on top, I have 5 times 12, or 60. And on the bottom, I have my 19. Again, if you are trying to figure out your side numbers and you're having a lot of difficulty, pull out your calculator and just start off to the side, writing down all the factors of 60. So I start with 1, and 60 divided by 1 is 60. And then I start with 2, and 60 divided by 2 is 30. And then I go to 3, and 3 divided by 60 is 20. And then I go to 4, and 60 divided by 4 is 15. Now I'm going to stop here, but I could have kept going on down, and really you go until basically your numbers start repeating, and then you know that you've gone through all the factors of 16. When you stop and you look, and I'm going to stop right here, when you stop and you look at those choices, the only choice that multiplies to 60 that looks like it's also going to give me a 19 is the 4 and the 15. So I plug those in, and they would be positive because they're going to multiply to a positive 60 while adding to a positive 9. So my side numbers are 4 and 15. Do not write this in parentheses. I have an a that's not 1. That's my 5. So I need to rewrite the 5n squared. I need to rewrite the plus 12. And now in the middle, instead of writing 19n, I'm going to write it as 4n and 15n. Your order is not important. You and I will end up with the same answer in the end, no matter which order you put the 4n and the 5n in. It doesn't make any difference in your final answer. So let's group the first two and the last two. When I group the first two, they both have an n in common. So I have 5n plus 4. When I look at 15n and 12, I have a 3 in common. Again, I have a 5n plus 4. Your parentheses should be the same. If they're not, go back and double check your work. So now I'm going to factor out my 5n plus 4. So I have 5n plus 4 times my leftover is an n. My leftover in the second term is plus 3. And this is my final answer. I can FOIL or box that to see if I get my original trinomial back. So when you're doing these types of problems, make sure that you look for a GCF first. That can simplify your math. And secondly, don't forget you're changing this to a factor by grouping problem. A popular mistake is to take the two numbers in the side and simply write them in parentheses. So like n squared plus 4 and n squared plus 15. But the problem is you've just lost your 5. That's why we needed a new method. Our a is not 1. Our a is a number other than 1. These are not like the problems on the front side. And so we needed a new method to handle those. Okay, so let's take a look at our last factoring review from last year. This is the difference of two squares. Last year I like to call this dots. This is the difference of two squares. So when you look at these problems, you'll notice they are not trinomials. They have two terms, and both of these terms are perfect squares. And so notice that it's the difference. We don't have any way to factor the sum of two squares, and I'm going to talk about that in just a moment. So there's no way to do that. But let's look at these problems. Notice all of them are the difference of two squares. Oh, sorry, I thought I was on my highlighter. Notice that they're all the difference of two squares. So this problem is very simple. You take the square root of the first and the square root of the last. So let's pick number 19 to look at. If I'm going to do the square root of the first term, I get 5x. And if I do the square root of the last term, I get 11. So those are the two numbers that go inside my parentheses. And notice one set of parentheses gets a plus sign, the other sign gets a negative. That's my pattern for factoring the difference of two squares. So my first parenthesis would be 5x, let's say plus 11. And my second set would be 5x minus 11. So last year when we did this, we realized that we had to change signs. We had to have a one positive and one negative, because when we box or FOIL, then my inner and outer terms cancel. And you're going to get 25x squared minus 121 back. So again, if you're ever worried about your answer, just double check it by boxing or foiling your answer. Let's take a look at one more problem. Let's take a look at number 21. Again, I look at the first term and I take the square root and it's 7x. I look at the second term and I take the square root and it's 9. I'm not concerned about the negative. The negative doesn't concern me because it's part of my pattern. It's part of my formula. So I only need to think about my square roots, and then I simply put them in parentheses. One parenthesis will be a plus, the other parenthesis is a negative. So this becomes 7x plus 9 and 7x minus 9. Again, if I'm worried I did it correctly, box or FOIL, and you're going to find your inner and outer terms cancel, and you get 49x squared minus 81. I want to remind you, in case you are wondering why I'm not solving these, last year we learned in Unit 6 about factoring, and in Unit 7 we solved quadratic equations. Solving is different. When I solved a quadratic equation, I always had an equal sign, and then it would be equal to something. And before I would solve, I'd want it to be equal to 0. So as a reminder, I would factor like normal. Notice that my A is 1. This is a very simple factoring problem from the front side. I would put the 18 on top. That's my A times C. I'd put the negative 9 on the bottom. That's my B. And then I pause for a moment and I think about different things that multiply to 18. In my head, I'm thinking about 1 times 18, 2 times 9, 3 times 6. And then I pause when I realize that my 3 times 6 multiplies to 18, and 3 plus 6 adds to 9. So when I put in my 3 and 6, I realize it has to add to a negative 9. So let's make that a negative 3 and a negative 6, and then double check. Negative 3 times a negative 6 is indeed positive 18, and negative 3 plus negative 6 is indeed negative 9. So when I write my answer, because my A is 1, I can put this right into my parentheses. This would be x minus 3 and x minus 6, but now it's equal to 0. And so we learned last year by the zero product property, that means that either my x minus 3 equals 0 or my x minus 6 equals 0. And so when I solve that, x is either 3 or x is equal to 6. These were my answers. They were the zeros for my parabola. This parabola crosses the x-axis at 3 and 6. And if I plug a 3 into my original equation, I will get 0. And if I plug a 6 into my original equation, for my y, I would get 0. So this was solving, which is different than just factoring. You need both those skills in your Math 3 or Math 3 Enhanced class next year to work with all kinds of functions, including polynomials and radical functions and rational functions. Thank you.